Hello everyone and welcome back. In a recent video, I went over the basics of how to get started with loops in Python. In this video, I want to go over the basics of how to get started using functions in Python. I'm working in a main.py file that has a lot of code from previous videos in it. You don't need any of this code though to follow along in this video. I'm just going to continue where I left off in the last video on loops. I will do one thing though, which is comment out this while true loop that we wrote in order to see an example of how to use the break keyword. That way, every time I run this code, I don't have to enter stop in order to see the output from the code we're going to write related to functions. So let's start right away with some comments on functions. First off, what is a function? So a function is a named sequence of statements. There are two main parts of working with functions. One is the function definition, and two is the function call. We can actually call functions that we didn't define, and we've been doing that a lot in this video series. For example, already on this screen, I can see two functions that we've called that we didn't write. For example, print and input. These are two functions that were defined by some other programmer or set of programmers and made available for us to use by simply calling the function. There are quite a few other functions that we use on a regular basis that we didn't write. So let's scroll up a little bit and see some examples. Range is an example of another function that we call. We've written a lot of code. Type is an example of another function that we call. And it looks like those are the ones we've used so far. I think we also did an example of converting a string to a numeric type. Let's see where that's at. Right here, perfect. So we were calling the int function in order to convert a string into an integer. And I just saw round right here. So we were passing in a floating point number and a number of decimal places to round that floating point number to. So there are lots of examples of functions right there. So I'll write a few more down. Int, type, round, etc. So now we are going to define, or AKA write, our own functions. So generally, functions take inputs and produce outputs. Now, I'm going to elaborate with some terminology here that's good to know when starting to work with functions. By inputs, I mean two things. One, arguments that are passed into the function when you call it, and parameters that are variables defined in the function header that store these incoming arguments. When we see our first example of a function that has an argument and therefore a parameter, I'll clearly label these so you can see them in action. Now for produce outputs, more specifically, the terminology we use would be return a value or return a result. And if you're coming from another programming language, you might have noticed I said produced outputs, where you might be like, oh, okay, well, a function from like C++ or Java can have a return statement where one value is returned. Well, in Python, you can actually return multiple values. So I'm going to put S's on values and results. All right, let's see the general structure for a function. Functions in Python start with the def keyword, short for definition or define. Then we have the name of the function. In Python style or Python convention, we use snake case to name our variables and our functions. Then we have an open paren, closed paren, And in here, we put a comma-separated list of parameters. And remember, a parameter is really just a local variable, meaning it's defined inside of the function that stores incoming arguments. Those are the inputs. Then we have a colon, and I'll put a comment on this comment line to say this part of the function is called the header. Then we have an indented body, and this is one or more statements that should execute when the function is called. So together, the definition is function header plus function body. All right. One more comment I want to make about a function header versus the function body. So Python executes code from top to bottom. So when it comes to a function definition, it essentially makes note of the function name and the parameters so that later when it comes across a function call, it knows if the call is correct and it knows where to find the code to execute. That being said, the body of a function does not execute until the function is called. Okay, so let's get started. We're going to do several examples. Let's start with example 1, the simplest case of a function. Example 1, we have no parameters, meaning no arguments in the call, and no return value. So this function takes no inputs and produces no outputs. So not a very exciting function, but functions like this do exist. All right, so let's have a very simple function called say hello, and all this function does is print out the string hello. Pretty much overkill to have a function to do this, but it's nice to start with a really simple example and then we'll add some more complexity. So if I run this, I don't actually see hello. Why? Remember what I said on line 230. The body of the function does not execute until the function is called. So Python executes main.py from top to bottom. When it gets to line 233, it's like, oh, okay, function definition, say hello. Now I know about say hello. And so if any code later tries to call say hello, I'll know what to do. Well, there's no code later that calls say hello. So let's not forget to do that. This is a function call. And this is what causes the body of say hello to execute. So now when I run this, I do see hello. Now I'll mention that we have to have the definition for a function before the call to the function. So I do have to have this block of code above this line of code. If I were to say flip these, let's try it so we can see what it looks like. We would get an error. So it says, oh no, line 233 right here, name say hello is not defined. So you're trying to call a function that Python has not yet seen the definition for. Remember, Python executes code from top to bottom. So let's undo that. And now one thing that's nice about functions is you can define them once and then call them multiple times. So let's say, for example, I want to call say hello in a loop. I can do for underscore. This is what's known as an anonymous variable. If you don't need a variable name in your for loop, or in other cases, you can just use an underscore. So I'll say for anonymous variable name in range, say 5, I'm going to call say hello. So now say hello runs 5 times. Now remember, this function is really short, but imagine a function that does a lot of work, right? Let's think about maybe converting values in a list of strings to be integer, right? Or maybe taking values that are floating point numbers in a list and rounding them into, say, the nearest 2 decimal places. It'd be nice to write a function to do that, and then we could call that function multiple times for multiple lists. So these are building blocks for much more interesting and reusable things. All right, time to move on to example 2. So with example 2, we will have one parameter, which means we will have one argument in the call and no return value. Essentially what we're going to do for example 2 is we're going to parameterize example 1. So instead of have a function that always says hello, let's just have a general function called say that says whatever message is passed in. So right here, this is our parameter list. We have a variable, a parameter called message. It's going to store an incoming string or value that should be printed out. So now I'm going to call this function, and let's try passing in a few different strings or really values of any type. So maybe I'll do hi there, goodbye, and maybe Python is awesome. So I run this and I see those strings being printed out, and you might be like, oh, well, I could have just written a print statement. But what if I wanted to, say, put a custom little prefix message, like something like message received? I could just put that in one spot, and then I would have essentially the change in my functional output in 3 spots. So once again, this is that kind of nice write once and then call multiple times. If I had just used print statements for line 24 through or 244 through 246, then I would have had to have added this code change in 3 spots. But here I only had to add it in 1 spot. All right, so now's a good point to try writing a function definition and calling that function yourself. So here's a simple task to pause the video and try out. And if you get stuck, you can take a look at example 1 and 2, or just resume the video because I will go through the solution and hopefully help you get unstuck. All right, so here's the task. Define and call a function that accepts the radius of a circle and prints out the area of that circle. And in order to solve this, you will need the formula that relates circle's area to its radius. So that is area is pi r squared. Pi times radius squared. So go ahead and pause the video and try this out. All right, let's go through the solution. You can name this function whatever you would like. I like to name my functions such that they start with verbs because functions do things, they're operations. So I'm going to call this compute circle area, and we're going to be accepting an incoming argument representing a radius of a circle. So I need a parameter to store that incoming radius. And now in here, I'm going to define a new variable to store the result of our formula. So I'll do math.py. If you want to use math.py, you will need to import math. Otherwise, you could just use 3.14 for the sake of this demonstration. So pi times radius squared. And now I'm going to print out area. Okay, remember, this is just the function definition. Let's see a call. So I'll do compute circle area, and I'll pass in a simple value like 5, and we see the area of a circle. Now, we've got 2 examples here, example 2 and the task solution, where we have a function that has 1 parameter. So I said earlier that I would clearly label argument versus parameter. So now that we have 2 functions that could be labeled, let's do it. So on 244, hi there is the argument. Arguments are inputs specified in the function call. On 245, goodbye is the argument. And on 246, Python is awesome is the argument. Now, each time say is called, the argument is copied into the parameter. So line 244 executes, hi there, the string is copied into message, and then line 242 executes, and then line 245 executes, goodbye, the argument is passed into message, the parameter, and then line 242 executes, and then line 246 executes, Python is awesome, the string is copied into message, the parameter, and then line 242 executes. And then we resume at line 246, got a bunch of comments. Okay, then we see line 251, a definition for another function. Okay, then we skip over the body. Line 254 executes. This is a call to compute circle area where 5.0 is the argument. 5.0 is passed in to radius, the parameter. So line 251, radius stores 5.0. Line 252 executes, radius is u, so 5.0 is squared and then multiplied by 3.14-ish. Stored, the result is stored in area, and then line 253, print area executes, and then execution resumes at the next line of code after the function call for which there is none, so then our program terminates. All right, let's bump up the complexity now. So example 3 is one parameter, which means we need one argument in the call and one return value. What I'm going to do is simply copy our compute circle area. I'll call it compute circle area 2. And I'm going to change the body of compute circle area 2 such that instead of printing out the area, we are going to return the area. So this means that compute circle area 2 has a output, a result, that needs to be returned or sent back to the calling code. So the calling code is any call to this function. So now compute circle area 2 returns a value, and we need to do something, or we should do something with that value. So here are a few things that I could do with that value. I could store that value in a variable. So maybe I'll call this result. I could call it area, because this would be a different area than the one declared in scope of the function. But I'm going to call it result just to make it really clear that this is a different variable. Let's print out the result. And we should see the same result that we saw with the task solution. And we do. I could also use the return value from a call to compute circle area 2, perhaps as the input to another function. So maybe I'm going to do print result rounded, and I am going to call compute circle area 2, passing in 5.0. This is going to evaluate to a return value from this call, and I could put that whole return value into a call to round and round the result to 2 decimal places. And then let's do one more example of something that we can do with a return value from a function. Let's do something like area doubled. And here I'm going to call compute circle area 2, pass in 5.0, and I'm going to multiply it by 2. So now I get 78.54-ish times 2. So what I'm trying to show you here is when a function returns a result, as compute circle area 2 does, you usually want to do something with that return result. Here are 3 easy ways to figure out if a function returns a result based on its call. Is there an assignment, in which case the value is being stored in a variable? Is that function call included as an argument to another function call? Or is that function call used in, say, an arithmetic expression, in which case whatever the return value is will be used as part of that arithmetic expression? So here, the return value from compute circle area 2 will be the left operand of this multiplication operator. All right, we're moving right along. Our next example is example 4. With example 4, we're going to have one parameter and 2 return values. So let's once again copy our compute circle area, but this time I'm going to copy compute circle area 2. And I'm going to paste it. I'm going to rename this function, for example, for compute circle area and circumference. If I can spell that, circumference. So given the radius of a circle, we could compute both its area, which is pi r squared, and its circumference. So I'm going to add more to the body of compute circle area and circumference to compute the circumference. So this is 2 times math dot pi times radius, 2 pi r. Now I want to send both the area and the circumference back to the calling code. So essentially the calling code kind of gets 2 results for one function call. So I'm going to return both area and circumference by simply specifying a comma-separated list of values. Now, what's happening here is it looks like I'm returning 2 values, but what's actually happening is I'm returning one value, which is what's called a tuple, and that tuple has 2 elements. So a little note here creates a tuple, and a tuple is an immutable list. If you haven't worked with lists before or tuples before in Python, no worries. I'll show you how to get these 2 return values out from the call to compute circle area and circumference. This is just me kind of nerding out and giving you a preview of what's to come when learning Python. Immutable means that it cannot be changed. So once created, the elements of a tuple cannot be changed. So imagine just taking like 2 items and putting it in a box and then giving the box back to someone. So this is essentially what's happening here. Area and circumference are being boxed up in what's called a tuple. And then when we call compute circle area and circumference, we have 2 choices as to what we do with the tuple, or in my analogy, the box with 2 items in it. So we could say just keep them together in the tuple and say, okay, compute circle area and circumference returns one item called results, and then I can print out results and we'll see both of them there. So here's the area and here's the circumference. And then I could access each one of the elements in the 2-element tuple by simply using zero-based indexing. Also a fun topic to come in future videos related to lists and tuples. So the first element is area, which is at result sub 0. The second element is circumference, which is at result sub 1. And now I can access them independently. So this is kind of the, I'd say, more advanced way of doing this. Typically what people do when there's a function that returns multiple values is they immediately unpack those values into variables. So let's say I have result 1, comma result 2. I'm going to let Python unpack the area and circumference from the tuple into 2 respective variables, result 1, which will store area because area was the first value returned, and then result 2, which will store circumference, which was the second value returned. So now let's do result 1, result 1, result 2, result 2, and then I'll print this out. And here's just another way to grab those 2 return values by using something called tuple unpacking. Essentially, you don't have to work with the tuple at all because its elements are immediately unpacked into respective variables. Just remember that the order does matter. So this was area first and then circumference second. So result 1 will store area first and then circumference second. All right, so far so good. We've covered a lot. The only thing that we haven't covered is having multiple parameters. Having multiple parameters is fairly straightforward because you just add another parameter to your parameter list, and the parameters are separated by commas. So let's do an unofficial example 5. I'm not going to label it example 5, where perhaps I do something like add, and then I have A, comma B, and all I do is add the two elements together. So then when I call add, I'll just pass in like 2 and 3, and then I'll see 5. So just like with tuple unpacking, if you have a function with multiple parameters, order does matter. So the 2 will be copied into A, the 3 will be copied into B. You can also have what are called default argument values, so that if, say, a function omits a value for a parameter, a default argument will be used to initialize the parameter instead. Let me show you example 5. So with example 5, we're going to see one parameter with a default argument. And we'll do and no return value. I'm actually going to borrow some code we wrote in the loops video to do this. There was a task where we wrote code to display the first 20 even numbers. Here it is. I'm going to bring that down. Let's call this function print even numbers. Print even numbers is initially not going to take any arguments. I'm going to change that in a moment here. I'll paste that code that I copied, and then I'll call this function immediately. All right, so you can see the output here. Here's the first 20 even numbers. Now let's say I want to parameterize this function so that the stopping value can be passed in. And this will be an inclusive stopping value. So I'm going to replace 40 with stop. And now it says, oh no, type error, print even numbers is missing one required positional argument. So it's a positional argument because there isn't a default value. So that means when I call print even numbers, I have to pass in a value. But let's say I want to set it up so that there's a default argument value of, say, 20, which is used whenever the calling code omits passing in an argument to be stored in stop. So now I could actually call print even numbers without passing in an argument. In this case, stop will be initialized to store 20, which is the default argument value. Now, when you add a default argument value, as we've done here with stop, there's an even cooler way of calling print even numbers, which is you can specify the name of the parameter for which you're providing an argument for. So let's say I do stop is assigned 10, and now my call to print even numbers is pretty self-explanatory, right? I'm going to print the even numbers stopping at 10. And there I see my output where 10 is the last number that is included. So this is kind of a preview of what I would say is more advanced use of functions where you're starting to add what are called keyword arguments with default argument values. One last thing programmatically that I want to show you is the idea of docstrings. So if you use a function that somebody else wrote and it's part of, say, the standard Python libraries, it's built in, or maybe it's from a library that you installed and it's written by a programmer or a team of programmers that documented the code really well, you'll be able to see that documentation by using a built-in function called help. So what help does is it displays the docstring for a function or a module. So let's try this out. I'm going to call help and pass in the print identifier. Notice that I'm not putting an open paren, close paren on here. I'm just putting in the identifier for the function. So now when I do this, my terminal output changes a little bit, and it shows what's called the docstring for print. So it says help on built-in function, print in module built-ins. And then we've got the essentially header for print displayed here with the description, prints the values to a stream or to sys.standardout by default, optional keyword arguments. Well, now we know a little bit about keyword arguments, right? So keyword arguments include file, sep, end, and flush. So these are parameters in the function header that have default values that we could optionally provide different values for, just like we did on line 290. To get out of help, simply click down on your terminal and hit Q on your keyboard, and that should drop you back out to your normal output. I'm going to comment this line out, and now, as the last new thing I'll show you in this video, let's add our own docstring. So docstrings have to be the first comment under the function header. Typically you use triple quote block comments. And on the first line, depending on what standard you're following, you usually have a description. So I'll do something like a function that prints the first even numbers starting at 2 and stopping at stop. Now, what I can do is I could call help on print even numbers. And what's cool is I see the docstring that I just wrote right here. Help on function print even numbers in module dunder, main dunder. And by dunder, that's just short for double underscore. And here it is. We've got the function header and we've got the description that we wrote. So you can get some insight into how those docstrings work by starting to write your own docstrings. Let's wrap up this comprehensive introduction to functions with a last set of comments. It's going to be labeled why use functions. I've alluded to a few reasons already. One reason would be write once, call multiple times. There is a body somewhere out there that belongs to the print function. What if every time we wanted to print something out, we had to copy and paste that entire body? It would make our code really, really, really long, right? Instead, some awesome programmers made the print function so that they write it once and we call it multiple times. It helps keep our code short and readable. Secondly, functions help minimize redundant code. Like I said, if we had to copy and paste the body of a function every time we wanted to call it, we'd have a lot of redundant code. If we need to change something in that copied and pasted code, we have to change it in multiple spots every time we copied and pasted it, right? So every time you find yourself copying and pasting code, stop and think one of two things. One, could I write a function for this functionality and then I could parameterize it and call it multiple times, passing in different arguments for the parameters? Or secondly, would a loop be more appropriate? Am I trying to repeat something that could be driven, say, by a loop control variable? And then one more I'll put here, helps with code organization. Recall the definition of a function that I gave at the beginning of the video. I said that a function is a named sequence of statements. The name itself helps make your code readable, right? For example, the body of print is abstracted from us, right? Like we haven't seen the body of print and we don't need to in order to use it, right? In order to call it. But just writing print makes our code read very much like English, right? We're going to print j+2. We know what this function is going to do because it has a really nice name to it. Same thing with print even numbers. We're going to print some even numbers. So it helps make our code more readable. and it helps our code stay organized because typically you put your function definitions at the top of your Python file, and then you put your code or your function calls below the function definitions. So it's really easy for a programmer to find where the function definitions are, find where the calls are, if you follow good convention and good organizational practices. Well, that's everything for my introduction to functions in Python. I hope you learned a lot and have some ideas for practicing. Perhaps take some code that you've written prior to this video, whether it be part of the video series or just part of some code that you've been writing for a project or an assignment, and you try to rewrite it using functions. A good rule of thumb to remember is one function should solve one task by implementing one algorithm. Thank you so much for watching. Consider subscribing to my channel and see you in the next video.